Welcome back. Today we're going to talk about the law of cosines. Now, unlike the law of sines, which is really straightforward to remember, okay, it's just the three fractions. The law of cosines is a little bit more complicated formula, but the good news is about the law of cosines is there's a nice little pattern we can follow. So here we go. It's a variation of the Pythagorean theorem. So this is the Pythagorean theorem. A squared equals b squared plus c squared. Kind of the Pythagorean theorem, right? But we need to account for the fact that these are not right triangles, okay? So not for right triangles. Okay, so we're not solving right triangles in these. Cool part about the law of cosines is we can use this to solve other triangles that the law of sines can't help us solve. So the first variation, there's going to be three. The first variation is a squared equals b squared plus c squared minus 2b times c times the cosine of A. And a good way to remember this is the A side and the angle. So when you're using lead with the A side, then you're going to do the cosine of A. So you're going to see a pattern here. So b squared equals a squared plus c squared minus 2ac cosine of b. And c squared equals a squared plus b squared minus 2ab cosine of c. And so the game is really which variation do I use? And you'll kind of see how this goes. So take a look at this real quick. Solve triangle ABC given that A is 11, B is 5, and C is 20. So what am I going to use? Well, you want to try to have the most things filled in and a way that you can solve meaningfully. If they give you an angle, you're going to use that angle. And so I'm going to use this variation, C squared equals 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20. Well, what is this gonna help me solve? Well, take a look at this. If I've got triangle A, B, C, and C is 20 degrees, this is obviously not to scale. I don't know A or B, but I have C, which is 20, and I have A, which is 11, and B, which is 5. This is a side angle side case. So one of the cases we can use is side angle side. And I guess I should have led with this. Why can't we use the law of sines? Well, I have this angle 20, but I don't have the opposite side. So you want to try to use the law of sines if possible, but if you can't, then you're going to need to switch to the law of cosines. And when I use this angle here, what am I solving for? Well, I'm solving for c squared, which is going to give me c, right? Then I will have a full ratio. I'll be able to use the law of sines. And so what am I going to have to do? I need to work on finding a way to put this in my calculator. Well, this is all calc work, right? So make sure you have your parentheses straightened out. And so c squared is going to be about equal to 42.63. So we're going to take the square root of both sides, and we're going to c is about equal to 6.53. Okay. So what can we do now? Well, now that I know that this is 6.53, it's also a rounded value, and so the law of sines would work, but wouldn't give us a solid answer. And since we're practicing using the law of cosines, let's just use the law of cosines again. How do I do this? Well, let's take a look here. If I want angle A, I'm going to start out for the formula that involves angle A. So that's the cosine A. Well, which variation is that? That's this one up here. So a squared equals b squared plus c squared minus 2bc cosine A. Well, what do I have? I have everything except cosine of A. And so I've got 11 squared equals 5 squared plus 6.53 squared. You could do 42.63 there, right? Cosine of A. All right, so this is where students get a little bit tripped up sometimes. So you got to kind of look at what's going on here. Oops, I forgot a part of the formula. I got so excited about the part where you trip up that I tripped up. How about that? So 5 squared, 6.53 squared minus 2 times B, which is 5, times C, which is 6.53, times the cosine of A. All right, so I need to respect the order of operations here, and I need to make sure that I'm solving this properly. Well, so I need to do 11 squared minus 5 squared, so I've got to move this to this side, and minus 6.53 squared. And then that's going to be equal to negative 2 times 5 times 6.53 cosine of A. So I'll need to divide by negative 2 times 5 times 6.53 and divide that by negative 2 times 5 times 6.53. So I'm actually going to be taking the inverse cosine of 11 squared minus 5 squared minus 6.53 squared over negative 2 times 5 times 6.53. Okay? Now, that's a lot to put into your calculator. And so my encouragement to you is make sure you have your parentheses straight. Okay? And when I do that, I get that C is approximately equal to 144.80 degrees. And so that's A. So A is 144. Again, this is not the scale. 0.8 degrees, and that's my A. I think I said C, but that should be A. And so then how do I find B? Well, I do 180 minus 144.3 minus 20 is equal to 15.20 degrees. This is 15.20 degrees. All right, so what's the long and the short of it? Use the information that you have to find the variation, and then use the law of cosines again. So that was side, angle, side. Here is one where they're giving me side and side and side. So this is useful also for side, side, side. And I'm going to draw this. A is 9, B is 7, C is 5. So let's see if I can draw this a little bit more to scale this time. So this is A, this is 9, and then B would be 7, and then C would be equal to 5. So this is a case where I have 3 sides and I have no angles. And so which variation of the Pythagorean, law of cosine should I use? It honestly doesn't matter. I'm going to start with this one. A squared equals B squared plus C squared minus 2BC cosine of A. And I've got that memorized because I've got this A, and then everything in the middle matches up. So 9 squared equals 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of A. So when I've got this, this is not something I can put into my calculator. However, I can subtract 7 squared plus 5 squared. So I've got 9 squared minus 7 squared minus 5 squared. All those are gone. And then I'm going to divide that by this part. So divided by negative 2 times 7 times 5. And that's equal to the cosine of A. So what do I need to do to find A? I do the inverse cosine of 9 squared minus 7 squared minus 5 squared times negative 2 times negative 2 times 7 times 5. Okay, these formulas is just working backwards. So I know I'm going through quickly, but you can definitely pause. Remember that? And as I'm working through this, just know that these formulas are going to become more familiar as you do this. Okay, so as you do this, it's going to become more familiar. So when I solve for angle A, let's see what I got. Should be 95.74 is equal to angle A. Measure of angle A is equal to that. All right, so I've got 95.74. Would love to use the 180 fact, but I can't yet. So I'm going to have to use another variation of the law of cosines. So I'm going to start this way. B squared equals A squared plus C squared minus 2AC cosine of B. So 7 squared equals, and then 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of B. I'm trying to squeeze it in, but I'm not trying to squeeze it in. I'm trying to make it look good. So now I've got 7 squared minus 9 squared minus 5 squared over negative 2 times 9 times 5. And again, you can simplify this. So like this bottom, this bottom is 80, right? So that would be negative 80. And so, sorry, negative 90. And so you can simplify some of these parts when you're putting them into your calculator. Don't feel like you need to do it like this. So like you can do 49 minus 81 minus 25, right, on top. And then this would be negative 90 on bottom. Okay, so that's all. You can do that. And that's allowed. And actually what that will do is it'll make it easier to put into your calculator. And what you get is 57 divided by 90, okay? And then that's equal to the cosine of b. And so what you can do is you can just do the inverse cosine of 57 divided by 90. And so these formulas look really complicated, but they're really actually a pattern. And then you can simplify a lot of stuff in there. So I've left it like this so you can see where all the pieces went, but just simplify them. Because when I do that, then I get the measure of angle B is equal to, it doesn't have to be a big thing you type in. It can be smaller if you get your pieces simplified, 50.70. And so then I've got C, the measure of angle C is 180 minus 95.74 minus 50.70. And so the measure of angle C is 33.56 degrees. So it's just using a variation of that formula, okay? All right, the other thing we can do in this section is we can find the area of a triangle in two ways. Here's the first one. So triangle area is equal to, and you're like 1/2 base times height. Duh, Mr. Saris. Well, that's really great if you know the height. The problem is sometimes we don't know the height. So this will be height known. All right? What if we don't know the height? What if we just have side lengths or we have some other little piece of information? So it can also be this. Triangle area equals 1/2 BC sine of A, or it can be 1/2 AC times the sine of B, or it can be 1/2 AB sine of C. What do you notice? There's a pattern here as well, right? And so that's one way, or we can do it like this. And I'm throwing a lot at you, but you're going to see how these kind of shake out. Or we're going to let the semi-perimeter of a triangle equal A plus B plus C divided by 2. Semicircle is halfway around. You're like, why are we doing this? It's part of the formula. So the semi-perimeter would be half of the perimeter. Perimeters, all sides added up. So for a triangle, that'd be A plus B plus C divided by 2. So if we kind of know that, and what I'm saying is you know 3 sides, you can find the semi-perimeter. The area can be equal to this. Square root of the semi-perimeter, so we're going to let that semi-perimeter equal S. Semi-perimeter times S minus A times S minus B times S minus C. So this would be like 3 sides known. Okay, so if I know 3 sides, this is my formula to use. Very simple, very straightforward. So this would be like 2 sides and angle known. Okay, so if you know 2 sides and an angle, you're going to use the first one, a variation of it. Second one, if you know 3 sides, you're going to use that. Okay, so then they give us this. I don't want to do that one first. I want to do this one. Area of a triangle with sides 13, 15, and 18. And so this is going to be, and I forgot to mention this. This is called Huron's formula. May you strive to have a formula named after you one day. But this is Huron's formula based on semi-perimeter, and it's with 3 sides known. So I'm going to use Huron's formula. And admittedly, it could be heron, but I feel like that's a bird. and it is. So I don't know, Heron or Heron's formula. And so I need to know that the area equals the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Well, what do I obviously need to know? A, B, and C. Oh, got it. I also need to know the semi-perimeter. So semi-perimeter is equal to A plus B plus C divided by 2. So 13 plus 15 is 28. Plus 18 would be 46. So it's 46 divided by 2 is equal to 23. So here's how it works. You ready? Mathemagic. 23 times 23 minus 13 times 23 minus 15. Oh, that's just confusing right there. I missed. 23 minus 15 times 23 minus 18. So 23 times 10, this is all under a square root. 10 times 8 times 5, which is equal to the square root of 92,000, which is equal to approximately 96 units squared. Approximately 96, okay? That is great if you have all three sides. What about this other word problem up here? Now, they're going to sometimes give you different information, but we're going to do this word problem together. And at first, you're going to be like, I don't understand this at all. This is really not. But draw a picture. Okay, for crying out loud, just draw a picture. Because if you draw a picture, you'll be able to see it. Find the area of a regular pentagon, okay, inscribed inside of a circle with a radius of 9 inches. Actually, this should be an octagon. I'm sorry about that. It should be an octagon. Find the area of a regular octagon inscribed inside of a circle with radius 9 inches. So let's draw an octagon. Here's the easy way to draw an octagon. Okay, you draw 4, and then you draw connecting 4. Connect 4. Inscribed inside of a circle of radius 9 inches, and so I'm going to do my best to connect the dots here. I think the kids say cringy nowadays. Maybe they don't say that anymore. I don't know. But the circle, it's all, ugh, I don't really love it. But it gets the job done. A circle of radius 9 inches means that from the center to the outside, at these vertices, at the corners, this is 9 inches, right? And so to find the area of this, it's really 8 of these triangles. And the triangle looks like this, right? 9, 9, I don't know everything else. But I do know that there's 360 degrees around the inside here. And there's 8 of these angles, so 360 divided by 8 is equal to 45, right? And so I know this angle is 45 degrees. So what can I do? Well, I've got this convenient formula up here, so let's just label before we do anything. A, B, C. So I have A is equal to 9 because it's opposite of A. I have B is equal to 9 because it's opposite of B. And I have the measure of angle C, which is 45 degrees. Check it out. Can't use semi-perimeter. I don't know what this is. It's not 9 because that's 45. If it was 60, it would be golden, right? Don't know it, can't use it. However, I have these formulas here, and I have A and B, right? And I have C. So I can use one of these formulas here to kind of like say my triangle area equals 1/2 A times B, which I have, times the sine of C. Okay? And so what does that mean? Well, that means that I can plug this in and say 1/2 9 times 9 times sine of 45. And when I do that, 81 over 2 times the sine of 45. And the sine of 45 I know. So what do I have to consider? Well, I have to consider the fact that this is actually not the area of the whole thing. It's actually the area of 1, right? So if I multiply this times 8, because there's 8 of those triangles, number of triangles in an octagon, sorry, number of triangles in an octagon, I really end up with 162 times the square root of 2, right? Because this is sine 45 would be root 2 over 2. Let me explicitly lay that out because that's confusing. Times root 2 over 2. So that's the sine of 45. So 81 over 2 times root sine 40. 81 over 2 times the sine of 45, which is root 2 over 2, times 8. And this would actually go reduce by these, right? So this would actually be 2. So this is going to be, because when it reduces by a factor of 2, it would be 4, and then another factor of 2. And so this is 81 times 2 times root 2 equals 162 root 2. And that's going to be in inches squared. Okay, kind of ran out of space there, but you get the idea. Draw a picture, see what formula, see what information you have so you can determine what formula to use. Okay, thanks for watching, guys, and we'll see you next time.